Hello, it's Ulysses, back for another Ask Our Experts episode. Today we will continue with the topic of clocks and timing, and more specifically, what makes a clock reliable. So Sieg, what is an ideal clock?
Put simply, an ideal clock is a clock whose frequency and phase remain exactly identical at all times. Let's start with frequency. Frequency is how often an event occurs within a specified interval of time. So for example, let's say that you like to take showers. You are clean. You shower at 7 a.m. every morning and you shower at 7 p.m. every night, every day of the week, every day of the year. The event is taking a shower. And the time interval where we're measuring that event is 1 day. So we have a frequency of 2 showers that are occurring in 1 day, or in other words, a frequency of twice per day, or 2 per 24 hours. Now, for clocks, electronic clocks in particular, we typically refer to a clock rising edge as the event of concern. And the time period that we use most often is a second. So for example, if I have 1,000 rising edges of clocks that occur within 1 second, that it has a frequency of 1,000 events per second, or 1,000 rising edges per second. And of course, per second is also the unit of hertz, so I could call this series of events a 1,000 hertz clock or a 1 kilohertz clock. Now, the question is, does this 1 kilohertz clock always stay at exactly 1 kilohertz? No, because no clock is ideal. No clock, going back to where we started this video, no clock is always at the exact same frequency and phase. So let's say, for example, I have a clock where during the first second, during the first time interval, during this first period, I have 1,000 rising edges. And say during the next time interval, the next period, I have 999 edges. And then let's say during the third second, I have 1,001 edges. Now, this is a simple example, but over this 3 periods, these 3 seconds where we measure this clock, the average frequency is 1,000 hertz. It's 1 kilohertz. But in reality, while this clock is running during this 3-second time period, the frequency is changing. And we need a way to quantify those changes that are occurring. If the frequency of a clock varies, even if the average frequency stays the same, this can cause issues in systems which, as I mentioned in the previous video, have these electronic clocks as their heartbeat, and these systems need a very regular heartbeat. Now, these clock non-idealities can lead to higher data error rates, but up to a certain point, all systems are designed to work properly, as long as these data error rates remain below a certain acceptable threshold. Now, if these clock non-idealities lead to data error rates that are above the threshold that the system was designed for, problems can begin to occur. And if the data error rate gets high enough, it's very possible that we could experience complete system failure. This, of course, is what we want to avoid.
Thank you, Sieg, for explaining what makes a useful clock. To our viewers, you can learn all about clocks and timing in our helpful links in the description of this video. And don't forget to subscribe to our YouTube channel to be the first to know when we have more insights from our experts. Bye for now.